some applications in 14.2. Okay, so we're going to go ahead and look at the concept of finding an area between two curves. So it has to do with an integral. So the idea is going to be, I'm going to use this diagram that I gave you just kind of to explain this. So the idea, one thing I want you to do on this is we've got two curves, and I want you to label this as A to B. And we're going to find, so far we've learned how to find an area under a curve and above the x-axis. That's what we've done so far. There's a lot you can do with this. In a business calc class, we usually finish up by showing how to find the area between two curves because it relates to an application we're going to look at. So I want you to label and just shade that region right there, and then we'll call that, just R. That will be the region like that. That's what we're trying to find. So it turns out what you do, you're going to set up an integral on this, and what you end up doing is you do this. The first thing you do is you do the area under the top curve. Okay, so we're going to do this area right here, right there, and that will be, a different region. I'm going to call that like R1. Okay, then what we do is we do the area that's underneath the curve that's on the bottom, and I'm going to shade that also. And then we're going to do something with it, and you want to make sure that this is logical to you. So remember, what we're trying to do is we're trying to find this area. Okay, you can find that area by an integral of that function from A to B. You can find this area right here of an integral from A to B of that. Now, does it make sense that if you took this area minus that area, you would get the leftover area? Is that logical? Okay, that's a big, this one is the whole area. That R2 is this little thing right here. So if you take the big minus the part, you're going to get what's left over. Okay, so the way you would set this up is like this. I want you to write this down. You would just say integral, when you do this, the integral of from A to B, of this region, and I'm just going to call that like some function. I'm just going to call this, let's just say R, like that, dr or something like this. Well, what you're going to do is you're going to do the area under the curve A to B of the upper curve. Then you're going to subtract. You're going to find the area A to B of the curve that's on the bottom, like that. So that's what you always do to find an area between two curves, is you take the integral of the top function minus the integral of the bottom function like that. Is that logical to everybody? Okay. All right. So we're just going to do a few examples to show how this works. So this is what the theorem says that I took out of the book. Again, you have a top curve, f of x, and you have a bottom curve. And what's important about this is if you're integrating from A to B, and this is real important, is this f of x has to be on top of g of x everywhere. Is that true? If it's not, you have to break it up into two integrals, and we'll see that in a little bit here. So what you do is you do the integral of from A to B of the top curve minus the curve that's on the bottom. That's what you do. That's how you set those up. And we're going to look at probably just two situations in this section. Okay? So the next page, I just kind of wrote this more in words. Just think of this as top curve minus bottom curve. Okay, that's the idea. And the thing on this is f of x has to have bigger values than g of x everywhere on that interval A to B. If it's not that case, if you had the curve kind of changed, where one curve is on top of the other for a while, then it flip-flops, then you can't do it this way. You have to do something a little bit different. Okay, so we're going to look at some examples. Some of these I went ahead and just did the graph. What we're doing in this case, in example 1, is we're doing this area here. Okay, so which curve out of the two is the one that's always on the top of the other? Square root of 2x or x minus 4? Which is the one that's higher? This one. This is the one that's on the top. Okay, this curve right here, this is the square root right there. Right? Okay, the line is this one. So you got to know the difference between those two curves like there. That's the one that's on the bottom. So what we're going to do is we're going to find this area. So the first thing you got to do is you got to figure out where you're going to integrate from. Okay. So what we're going to do is we're going to go from here to there, which is where those two curves intersect. It's pretty clear from the diagram it's 8. But you don't want to go by looks, unless that's given to you. So I want to show you how you find these things right here. So what we want to do is we want to find that point right there. Okay? So actually what we do is we just substitute one equation into the other. Okay? That's how you find intersection points, is you just set the two curves equal to each other. If you did that, you would have x minus 4 equals square root of 2x. Okay, and most of these problems are designed so when you do this, it's an equation you can solve. You don't have to use your calculator on it, okay? So I'd have to see on your background, do you guys know how to solve an equation? It's got a radical in it. Do you know how to make the radical go away? You square both sides, right? You raise both sides to the second power, and what that does is that removes your radical. What you have to understand from algebra background is anytime you do the square root of something squared, well, it's just itself, okay? So what we have to do is we have to FOIL this. So we're going to just write that as x minus 4. You can either write it out twice and FOIL, or you can just do that shortcut I've showed you. And then the right side's 2x because the radical comes off. So if you FOIL this, you're going to have x squared minus 4x plus 16 is equal to 2x, okay? And then that like term, you're going to have x squared minus 8x plus 16 equals 2x, okay? So that's how you get rid of the radical. What would you do next to finish this up?
Divide by 2?
Not yet. We have, anytime you have a x to a power, one side has to be 0, then you got to factor, okay? You could divide by 2, it just wouldn't do you any good. It's because you have a power, you have a quadratic equation, which tells you that you got to approach it this way. You need to get one side equal to 0. So just move the 2x the other side, okay? Collect like terms, you're going to have x squared minus 10x plus 16 equals 0. Okay, now what do? Factor. You hope it factors, right? Okay, so we're going to go ahead and factor this. And let's see, when we do this, what would be two numbers that multiply to give 16 that add up to 10? 8 and 2, good. Okay, if you don't know that, you could go the quadratic formula. So it's just x minus 8, x minus 2. So what are the two solutions?
8 and 2.
8 and 2. Okay, so we have x equals 8, x equals 2. Okay, so what's happening on this is you can tell by the diagram that the 8 is there. Okay, that's what that's given then, is that intersection point right there. Okay, so that means that's how we're going to set this up, is we're going to go from 0 to 8, like that. You can tell 0 because that's where the graph is starting on the paper. Okay, so what we have now on this, and if you're, the thing that'll happen on this is now we want to set up our integral. So what we're going to do is we're going to go from 0 to 8. Okay, and then which curve is on top? Which function? Square root of 2x. So we're going to say top, square root of 2x, minus bottom, which is x minus 4. Notice I got that instead of parentheses, dx like that. So that's what you got to do, is you got to do that integral to find that area. So it's always top minus bottom. Okay, like I showed you on the previous page. Now if we can do this integral, we'll have the answer to the problem. That's how you set it up. Okay, does that make sense so far? 0 to 8, top is the square root, bottom is the line. Okay, now let's see if we know how to do this integral. Well, what you have to do on this, you got to be a little careful about this. This square root of 2x could be written as square root of 2 times square root of x. And then you could distribute the negative through to get minus x plus 4 times dx. Now, if you don't know that, you would struggle getting this. But the thing is, what kind of number is a square root of 2? Isn't that just a constant? So that means that comes out of the integral C. So what we're going to have, we're going to break this up into 3 integrals like this. Okay, or you can kind of do this like this. So what we can have is we're going to do the integral from 0 to 8, moving that out, square root of 2, and then the square root of x. Well, I'm going to write that as x to the 1/2 because that's how you do the antiderivative. Okay. Then the second thing I'm going to do is the integral 0 to 8 of x dx. And then finally, I'm going to do the integral of 4 dx from 0 to 8 like that. So that's what we're going to work out. Now, you don't have to break it up that way. You can do that antiderivative in your head and then evaluate the whole thing at 0 to 8, which is, to me, is better to do it that way anyway. Okay? So what we're going to do is we're going to do this antiderivative, and that, and we're going to do every bit of that in our head. Okay? So I've got the square root of 2. What is the antiderivative of x to the 1/2?
X to the 3/2 over 3/2.
There you go. Okay, add to that. You can do that in your head. You add 1 to it. Okay, you're dividing by 3/2. Okay, so really what you're doing is that's 2/3 x to the 3/2. Okay, because if you divide by 3/2, you know that's the same as multiplying by 2/3. So that antiderivative, we still have that square root of 2 times 2/3, and then I've got x to the 3/2 like that. Okay, that's the hardest antiderivative on there. Has everybody got that okay? Okay, what's the antiderivative of x to the first? X to the second over 2, how about 4? 4x. Okay, good. So what we have is minus x to the second over 2. That's what that antiderivative is. And then this antiderivative is going to be 4x. Okay, so we have plus 4x. And then this whole thing is going to get evaluated from 0 to 8, the whole thing. Okay, like that. So see, you don't have to break the integral up if you don't want to. You do need to know that you're going to bring that out on this one piece there, and then that way you can just do the whole thing from 0 to 8. Okay? Otherwise, I mean, you could do each integral from 0 to 8. It's more work though. Okay? So what we're going to do on this then is, this gets a little messy, so what we're going to do is this. I'm going to write this as 2 root 2 over 3, and then we're going to plug in the upper limit. So we're going to have 8 to the 3/2. We'll talk in a minute about how you do that. And then minus, now plug the 8 into the next thing. So that's 8 to the second over 2. Then plug it into the 4x. Okay, that's the first part. Okay, then what you do is minus. Now it's nice if I give you a 0 because that makes it usually a little easier. So we're still going to have 2 root 2 over 3 times 0 to the 3/2 minus 0 to the second over 2 plus 4 times 0. So you're going to have that. Okay, so what we're going to do is going to work this out and get an exact answer. Now you could do this on a calculator, but I would like a student certainly to be able to do this without a calculator. So we're going to work this out. This is 2 root 2 over 3. Now watch this piece right here. What you do on the square root of 8, okay, you can change this to the square root, that's the second root of 8, to the third power. That's how you do, that's what a 3/2 power is it's the square root of 8 to the third. Okay, then you go here, that's going to be 64 over 2, and then this is going to be 32. Okay, what do you think is going to happen on the right here with all this stuff? It's going to be 0 because you're going to have 2 root 2 over 3 times 0. 0 to any power is 0. This is 0 over 2, and that's 0, so that whole thing becomes 0. Okay, so you're going to end up with this. You're going to have 2 root 2 over 3. This is really the square root of 64, and the square root of 64 is 8. Okay, so we have that. Okay, you got to know how to change a 3/2 power to a square root of something to the third. 64 over 2 is 32. Bring down the 32. Okay, all this stuff over here is 0. Okay, that's 0 minus 0 plus 0. Okay, 32's cross out. So it looks like the official answer, if you multiply this straight across, is 16 square root of 2 over 3. A lot of times, the hardest part of definite integrals for students is the arithmetic at the end. Because if you can do the integral okay, do the antiderivatives, you're going to get into some arithmetic issues when you do this. Okay, you guys see what I'm doing? You guys follow the arithmetic, tell me, I don't know. Okay, because that's usually what I experience in teaching this, is these little issues like that. Students don't know that from their background. Okay, let me show you how to tell you're right on a problem like this. So get your calculator out. Okay, really it's very, very easy on these problems to identify and tell that you're right. So what you're going to do is you want to put this in. You want to put in the integral that we did. The integral that we just got through doing was this right here. So we're just going to put in square root of 2x, and then minus, and then we can put parentheses, or you can distribute the -3. I'm going to just put in exactly the way we set that up. That was the top curve minus the bottom. Now when I graph this, it isn't going to give the graph that I gave you. It's going to do a graph of the integral, but it'll still allow us to check our answer. So let's, for a window, go, let's go 0 to 10. And like that, scale of 1 for the x, and then for the y's, let's say, I'm just taking a wild guess on this. Let's say -10 to 10. I don't know if there's any negative region on this or not, so let's just go -10 to 10 by a scale of 1. Okay? Now when you graph this thing, what it's going to do, it's not going to graph this, so don't let that confuse you. We're graphing this function. Okay, so if I type graph, we should just get one region like that. Now what you're going to do is you're going to go from 0 to 8, because the integral goes from 0 to 8. So you go second trace, option 7, lower limit is 0, upper limit is 8. It's going to shade that, and it's going to give a decimal answer on this. And what we're going to do is compare our answer to the decimal answer. Now remember, don't let this confuse you. We're finding this region. It turns out this region is the same as that region. We're graphing this. Does that make sense? Okay. So what we have on this is 21. That looks like that gave me 21.3. Now what I'm going to do from this is I'm going to take my answer. I'm just going to compare that on the calculator. So my answer was 16 times the square root of 2. And then I'm going to divide that by 3 and put it in like that and see if it's 21 point. Oh my goodness, did I do something wrong? I hope not. I'll double check though, because I got everything right in there. I got 2x.
16 square root of 2 is.
Did I make some mistake somewhere? Oh, I messed up on my. Oh, you know what? I know what I did. I did this. Okay, one little thing right here. If you look at this, no, that's okay. Square root of 60. That's 8 to the third is not 64. Okay, that's my issue is that. Okay, so let me go back and fix that. Now, that's why you want to learn how to check too, because it's easy to make little slip-ups like that on the arithmetic here. The way you would do this is like this. You can do 8 to the second times 8 to the first. And if you do the square root of anything to the second, it's itself. So you'd have that. And then, I mean, if you're simplifying this, you could also go like this. That is, square root of 8 is 4 times 2. Square root of 4 is 2 square root of 2. So this whole thing right here is 16 times the square root of 2. That's what that is. Okay? And that, again, is background stuff right there. If you're doing a square root of an odd exponent, you break it up into an even exponent and one left over, and then simplifying the radicals, which we've done a little bit. So what I'm going to have is 2 times 16 is 32. Then I've got square root of 2 times 2 is square root of 4, all over 3. So that actually gives 32 times 2 over 3, so 64 thirds. Should be the answer. Now let me see if that matches up with what I have on the calculator. So if I do 64 divided by 3, that sounds like that would be right. 64 divided by 3 is 21.3. That's what the calculator gave you. Okay? So my issue on that is I messed up with this thing right here. Okay? Now if you're getting a decimal answer, you would just take the 64 divided by 3 and round that off on your calculator. Okay? All right, you guys got any questions about anything I did there? Okay, the hard part is this right here for most students is the arithmetic. See, I made a mistake on one little thing because I wasn't paying attention to the third power. I was doing 8 to the third is 64. That's an arithmetic issue. Okay, let's go to the next one. Let's do a few more of these and kind of get the ideas. Okay, first thing we're going to do on example 2 is I've given you the region that we're doing, and I've given you the two curves. So what you want to do on this, first of all, is you want to figure out where you're integrating from. And you're always going to be integrating from left to right for what we're going to do in this class. So it looks like you're going 1 to 4. Now, don't always go by looks. Now, I think most of these problems are kind of designed so that they're set up that way. But what you're going to do to find these limits 1 and 4 is you're going to take this function and set them equal to each other. In other words, you're just substituting into the top equation and the bottom equation. So you get x to the second minus 4x plus 3 equals x minus 1. Just like we did the last problem. Now, how do you solve that equation? One side equals 0. Good. This is a quadratic equation. Anytime you have x to a power, you need to have one side equals 0. So I'm going to move all this stuff from the right side to the left side. That's going to give x to the second minus 4x plus 3 minus x plus 1 equals 0. Make sure that you change those signs because you're subtracting x and adding 1. So that's going to give x squared minus 5x plus 4 equals 0. This will factor, and it will factor as x and x. What are you going to use for your other numbers?
X minus 4, x minus 1.
X minus 4, x minus 1. Good. So just like we thought we would get, you get x equals 4, you get x equals 1. So you got to find those limits of integration unless it's just real obvious from the diagram. This one's pretty obvious, okay? All right. So now we're going to set up the integral. All right. So what you're going to do is go from 1 to 4. Now, which of the two curves is on the top? X minus 1, the line, okay? This one right here that I'm highlighting is x minus 1. So that one comes first. The one that's on the bottom is the parabola. So that's going to be minus parentheses x squared minus 4x plus 3 times dx. Remember, you're always doing curve on top minus curve on bottom. Okay, don't do it backwards. If you do it backwards, you'll get an opposite answer. You'll be off by a negative, so you don't want to do that. Okay, so what we're going to do from here is it's a good idea to simplify all this. You've got a bunch of like terms, so I'm just going to write this as integral 1 to 4 x minus 1 minus x squared plus 4x minus 3 dx. Okay, you want to do that and collect your like terms. This integral should be a pretty basic one to do. So I'm going to have, doesn't matter what order you put it in, negative x squared, and then 1x plus 4x is plus 5x. Negative 1 minus 3 is minus 4 times dx like that. Okay, so you want to get everything simplified, then you're ready to roll. Everybody with me so far? Okay, well, let's do the antiderivative. Tell me what the antiderivative of negative x squared is. Yeah, okay, power rule, right? Okay, what's going to be the antiderivative of 5x? Power rule, x to the second over 2. And then how about 4? 4x. Now, you don't put the plus c because it's a definite integral, but that is your antiderivative. So what you're going to do is negative x to the third over 3 plus 5x to the second over 2 minus 4x. This thing gets evaluated from 1 to 4. Okay? So now we get into the arithmetic. So if you got that part, usually students do well with this. That's from experience, but the arithmetic gets kind of heavy sometimes. Okay, so what do? We plug the 4 in to the antiderivative. So we're going to have negative 4 to the third over 3 plus 5 times 4 to the second over 2 minus 4 times 4. You do that. Then you plug the 1 in and you subtract. That's the fundamental theorem of calculus. Okay, so you're going to put in negative 1 to the third over 3 plus 5 times 1 to the second over 2 minus 4 times 1 like that. Now, you can use your calculator to help you with stuff too, okay, if you want to. Okay, so let's see what we get. We try to get an exact answer on this.
Is it minus a negative 1?
What's that?
Like that you have minus negative 1 to the third over 3?
The negative came from here in that antiderivative. Because remember, we had negative x to the third over 3. That came from the fact that we were doing an antiderivative of negative x to the second. So I got that right, okay? All right, so let's go ahead and finish this up then. So this 4 to the third is 64. You'd still have the negative, so that's negative 64 thirds. This is going to be 5 times 16 over 2. And then 4 times 4 is 16. So we have that. You just kind of write steps out carefully. Then 1 to the third is 1. So that's negative 1/3. This is 5 times 1 over 2. That's 5 halves. 4 times 1 is 4. If you're something you can do in your head, do it in your head. Okay? Now I'm going to do one more step, and then I'm going to show you. I don't care if you guys do this on your calculator with fractions to save time. This is going to be negative 64 thirds. Let's see, what's 5 times 16? 80, I think. That's 80 over 2. Okay, now I'm going to go ahead and do this in my head. This is 80 over 2 is 40, so you could write that down as 40. Okay, now watch I do this. I'm changing the signs. So this is minus minus, or plus 1/3, minus 5 halves. Okay, and then minus minus 4 is plus 4. Now see, if you get something like this, you would be forced to get common denominators, and you're more than welcome to do it that way if you want to. I think in this class, and I think in any calculus class, I would ultimately like students to do that by hand, but also use your calculator. What I'm going to do is this. I'm just going to plug it in my calculator, and I can get my calculator to change it to a fraction answer. So I can put in 64 divided by 3. 80 over 2 is 40. You can put 80 over 2 in. I'm doing that in my head. That's 40. Then minus 16. And then plus 1/3. And then minus 5 halves. And then plus 4. Now you're going to probably get decimals on this then. So that gives 4.5. Okay, like that. All right, now, if you want to change this to a fraction, so if I wanted a fraction answer, you could say 4.5, but you can also go like this. You can go math, fraction. So if you type the math button, option 1, press enter, it just changes it to a fraction for you, so you get 9 halves. Okay, so you can get that answer that way. When you get down to the end of these problems, you can use your calculator to do all that fraction arithmetic. Okay, I might as well in this class. What do you think? That's what I do. Okay, all right. So that would be the idea with that then. Okay, so that's the idea. Let's do a real quick check on our calculator, then we'll take a break here. So we got 9 halves. You guys got any question about how I did that with the arithmetic or anything? To me, that one's not too bad. So check this way. You want to go back and put in this thing right here. I would just put in what you set up. Okay, now you can leave the parentheses off x minus 1 if you want to, but you can put it in too. I'm just going to put it in exactly as it is. That's what I recommend. That way, in case you made a mistake with changing your signs, you're checking the right thing. So I'm just doing top curve minus bottom curve like this. Okay, so we're going to graph this. Now this is going to give us a way to check our answer. For the window, our integral's going 1 to 4, so I'm going to go 0 to 5. I think it's always good to go a little bit below and a little bit above the limits of integration, because if you don't, there are times when you'll get an error. We'll leave negative 10 to 10 and see if that's good enough. I'm just going to do a window like that, graph it, and then we're going to do an integral from 1 to 4. Okay? All right, so I just go second, trace, option 7. Okay, lower limit is 1, upper limit's 4. What did we get? 4.5, I think, so, or is that what we got? Okay, 22.5. It's possible I got an error in there, because that arithmetic sometimes you got a problem with. What did I do?
I think you entered it wrong.
I may have. Oh, I got a plus. Yeah, okay. All right. Okay. Let's fix that and try again, because I want you guys to know how to check and verify these things for like your final. Okay. Now let's see if this works. Okay. Yeah, you got an area from 1 to 4, so it should work out now. So option 7, lower limit 1, upper limit 4, and 4.5. Let's see if we got it. Okay, got it. That's how you do. That's all you got to do to check. You can verify these things until you're right pretty easily. Okay, so probably the big part of the problem that you got to pay attention to is how to evaluate that integral, like from 1 to 4. That's the part where you get into arithmetic, but get your calculator out and let you. Okay, so what I'm doing on this one again is I'm giving you the diagram and I'm giving you 2 curves, and we're going to find this region here. And really what you have here, you have to actually do 2 different integrals, and the reason is because this region right here, the top curve is the line. So this one right here, you might want to just write down what we're going to do is the top curve is 4x. The bottom curve is this polynomial, and I think that, boy, I didn't write that very good. I think that is a negative x to the third plus x squared plus 16x. I can tell that's what was intended. So see, just this little piece right here, the curve on top is the 4x, and the curve on the bottom is the cubic, but it changes. When you look at this region right here, then it's different. This integral would have to go like this. You would have to say the integral of the top curve, which is now negative x to the third plus x squared plus 16x, and then the curve on the bottom now is the line, so that's minus the 4x like that. So you actually have to do 2 integrals on this problem. You can't just integrate from here to here because this flip-flops. The top curve and bottom curve flip-flop. Does that make sense? So you actually have to do 2 integrals, and then you add the results together to get that total area. You have to. Is that rational? Logical? You got to pay attention. The reason you can't do 1 integral is because of that flip-flop. Okay? So what we're going to do is we're going to find the limits of integration. It's pretty obvious what they are. I'm going to go ahead and crunch out what they are. So remember, you're doing x values. So it looks like you're going to go from negative 3 to 0 here on this integral. And then it looks like on this integral, you're going to go from 0 to 4. Okay? You can go by looks. I'm going to go ahead and just show you what you would do if it's not obvious. Okay? So what you would do is you would do this. You would just set these 2 equations equal to each other. So you would do negative x to the third plus x squared plus 16x, and you would set that equal to 4x. Okay, that's how you find how to integrate from. Okay, I think the diagram makes it pretty obvious. Let's go ahead and do this. So how do you solve an equation like this? Well, you got to get everything on one side set equal to 0. So what I'm going to do is just slide the 4x over here to get negative x to the third plus x squared plus 16x minus 4x equals 0. Okay, I do have a like term that goes together. The 16 and 4 go together. That'll give negative x to the third plus x squared plus, what is that, 12x equals 0. Now you got to solve that equation. How do you solve an equation like that? You can factor an x out, right? Okay, now I'll tell you what I do. I just like doing this. You don't have to do it this way, but I usually like that first term to have a positive number. Now you can bypass this if you want to. It'll still work beautifully. I think the factoring is easier if you do it this way. So all I'm doing is just really multiplying everything by -1 to change the signs. Okay? I think you probably in the long run usually find it a little easier to factor if the highest power has a positive in front. That's why I'm doing that. Okay, now we're going to take an x out. So that will leave x squared minus x minus 12 equals 0. Okay? How about this thing that I'm highlighting? Does that look like it'll factor? Yeah, okay, I think so. X and x, 4 and 3 will give you 12. Okay, so we're going to factor that one more time. You still have the x. Okay, then you draw your two parentheses. This is, factoring what I have highlighted in yellow. You're going to have x and x, 4 and 3 to get 12. How do the signs go?
X minus 4x plus 3.
Good, x minus 4x plus 3. What are the three answers?
0, 24.
Yeah, that's x equals 0. This is x equals 4. That's x equals negative 3. So if you look at my diagram, so you can tell there's negative 3, there's 0, there's 4. So I told you you could go by looks, but I wanted to show you how you could do this problem in case you can't. Okay? So now what we're ready to do is set this problem up. This is going to be a pretty big problem to do because you got two integrals. So the first thing we're going to do, I'm going to call this region 1 and this region 2. So the total area is going to just be equal to the area of region 1 plus the area of region 2. I already set the integrals up for you. So the thing is, this first integral, R1, you're going to have the integral. Remember, the top curve here is 4x. So you've got 4x. The curve on the bottom is the cubic because it's the curved one. So that's minus negative x to the third plus x squared plus 16x dx. And then we're integrating from negative 3 to 0. Okay, does that look okay to everybody? Why I'm doing that? Top curve's the line, 4x. Bottom curve's the curve. Negative 3 to 0. You're always going left to right when you integrate. Okay, x values. Okay, then the second integral is going to be the integral from 0 to 4 now. And now everything flip-flops. The curve on top is the cubic. So you're going to have negative x to the third plus x squared plus 16x, and then minus 4x dx. So what you got to do is you got to work out those two integrals like that. Okay. Now the antiderivatives are just going to be backwards of each other. So I'll explain that when I get to this. So once you get one antiderivative of the first integral, the other one's just going to be totally backwards. The signs are going to be different. They're going to be opposite. So let's go ahead and start working on this first one. Okay, you can just collect the like terms. Now be careful when you do this now. So this is, I'm going to write this just kind of at the side. I've got 4x plus x to the third minus x squared minus 16x. You can do this in your head. And then you got to collect like terms. So I'm just changing that, distributing that negative through. So I'm going to have x to the third minus x squared. And then 4 minus 16x is going to be minus 12x dx. Okay, like that. Okay, so that's an integral we're going to do. That's a basic integral too. That's one that's easy to do in your head. You're going to get into some arithmetic then. Okay, go to the next one. What we're going to have here is negative x to the third plus x squared. I didn't need to do this. I can do this in my head. Okay, you can just put the like terms together, and I want you to show you that everything's backwards. You have negative x to the third plus x squared plus 12x. Okay, you guys see how this thing here is opposite of that? That's what you would expect because that's what happens if you subtract backwards. So what you're going to have here is you're going to have this integral of 0 to 4, negative x to the third plus x squared plus 12x dx. You can take a shortcut on these problems. So once you know what this is, you know that's just opposite. All the signs are opposite. Does that make sense? Okay. If you don't see that, you can crunch it out and you'll figure that out anyway. Okay. So now what we're going to do is we're going to do our antiderivative, and we got to evaluate. So this is going to be some pretty big arithmetic on this problem. All right. So the antiderivative of x to the third, what's that? X to the fourth over 4. X squared. X to the third over 3. 12x. Yeah, 12x to the second over 2, which, like you said, is 6x to the second. That's going to be evaluated from negative 3 to 0. Okay? Now, what's going to happen here is this is just going to be backwards. Okay, when you do this, it's going to be the same antiderivative, except the signs are different. So it's going to be negative x to the fourth over 4, and it's going to be plus x to the third over 3, and then plus 12x to the second over 2, and then that's going to evaluate from 0 to 4. So one thing I'd recommend is just change that 12 to 6. Okay, and that'll simplify your arithmetic. All right, everybody okay with that, with the antiderivative? Okay, no U sub or anything on this, straightforward power rule stuff, okay? All right, now let's see what we got, okay? And we got to crunch all this stuff out now. So what we have here is you plug the 0 in, so you're going to have 0 to the 4th over 4, 0 to the 3rd over 3, minus 6 times 0 squared. Okay, we got that. Now that's going to be 0, right? If you could do that in your head, you could just write 0. Okay, I wouldn't care. Now we're going to go minus. Now plug the negative 3 in, but be careful. The negative 3, when you do that to the 4th, it's got to be in parentheses like that. Same thing with the 3rd. It's parentheses negative 3 to the 3rd over 3. Then it's minus 6, negative 3 to the 2nd like that. Okay, and that's what you got to do is that arithmetic, that will give you the area under the first curve. Then you do the same thing over here, but now we're going from 4 to 0. Okay, so we do this, plug the 4 in. You're going to have negative 4 to the 4th over 4, plus 4 to the 3rd over 3, plus 6 times 4 to the 2nd. Then you're going to plug 0 in, which is probably going to make everything go to 0. So that's negative 0 to the 4th over 4, 0 to the 3rd over 3, 6 times 0 to the 2nd, like that. Oh God, I hope I have everything written down there. This is the part of the problem that's usually real easy to make mistakes on, because it's just arithmetic. Now we're going to use our calculator to help us a little bit on this problem if we need to also, though. Everybody okay so far? Okay, well, one nice thing about this is that whole thing's 0, and this whole thing here is 0, so that helps us out a little bit. So what I'm going to have is minus, and let's see, negative 3 to the 4th is positive 81 over 4, minus negative 3 to the 3rd is negative 27 over 3. Use your calculator if you have to kind of make sure you're accurate with that. And then negative 3 to the 2nd's 9, so that's 6 times 9. Okay, and then we'll crunch all that out in a minute. Okay, we go to the next thing. 4 to the 4th is 256, I think. You might check me, I think I'm right. 4 to the 3rd is 64 over 3. And then this is 6 times 16. So I'm just doing the exponents like that. I got the zeros, so I don't have to worry about that. Okay, so what I'm going to have is I'm going to do this now. I'm going to write this kind of a couple of more steps, then I'm going to go to my calculator. I have negative 81 over 4. 27 over 3 is 9. So that's a negative 9, so that's a plus 9. Got the minus minus there. Then 6 times 9 is 54. Okay. I'm pretty sure 256 over 4 is 16. Okay, just making sure because I don't make any more mistakes today. I got negative 16, 64 over 3, I'll leave it alone. And then 16 times 6 is 96. Okay, like that. All right, it's all arithmetic. Did you see something?
Positive 54, isn't it?
Now, it will be in a minute. Okay, but for now, see that thing became, this thing right here, when you squared it, became 9. Okay, you square a negative number, it's positive 9. So you have minus 54. Now in the next step, it's going to change because you have that minus in front of parentheses. Okay, so what we're going to have next, then we're going to go to our calculator. We have negative 81 over 4 minus 9 plus 54. Distribute the negative. Then minus 16 plus 64 over 3 plus 96. And you get down to a point like this, you might as well just get your calculator out and do it all that way, including the fractions. Then we can get a fraction answer on this, and I hope I didn't make any mistake anywhere. So,
256 divided by 4.
What's that?
Is that 16 from 256 divided by 4?
256 divided by 4 was 16.
264.
Yeah, I did that on my calculator. 256 divided by 4. Oh, hold on. I did 256 divided by 16. Okay, so let me fix that. Gosh, 64. That's what you said, isn't it, too? Okay, good. See how easy it is to make stupid mistakes on these things. I'm trying carefully, too. Okay, now I think we're good. So we have negative 81 over 4 minus 9 plus 54 minus 64 plus 64 over 3 and then plus 96. This is likely to give us a decimal answer. So I'll just write this in two ways. We could have 78.08, but you can also do this. Just go math, press your math button, press your option 1, your fraction, and it'll convert it to a fraction anyway. So that's going to be the exact answer would be 937 over 12. Okay, assuming I didn't make any arithmetic mistake anywhere. I don't think I did. Okay, and you can check that. I'm not going to take the time to do that, but the way you would have to check this on the calculator is you would basically have to do this integral and that integral on the calculator and add them together. And if you do that, it should work out. Okay, what looks like the messiest part of the problem to you? Arithmetic. Okay, it's not the calculus that's hard with this thing, it's the arithmetic. You got to be very careful, but let your calculator assist you with that, because that's what you're going to deal with. Okay? Okay, let's do this last example here to wrap this up. Now this one, I do want to have you do a graph on this one. So sometimes I give you the graph, like on the final, I'm pretty much just give you the graph. That'll kind of test you on the number one thing I want you to do. So what we're going to do is just graph both of these things. And I'm going to do this one at a time. So I'm going to start by putting in x to the third minus x squared. And let's do it in a standard window. Or actually, let's do like this. Let's do like negative 5 to 5. I think this one will, I want to get a little bit more accurate graph. Let's go negative 5 to 5 on both x and y, because I think my graph is, like when I was typing this up, I wanted it to go from 6 to 6 or something like that. So let's do a window like that. Okay, then I'll type graph. And let's just get enough points for accuracy. So what I would recommend you do is maybe look at your table of values. Okay, once you get x cubed minus x squared in, you can go second graph to open up the table. And let's just find some pretty good points here. Just enough. Let's do like negative 1, negative 2. We have 0, 0. We have 1, 0. We have 2, 4. And that's good enough. Then I'm just going to just sketch it from there. So you're going to have something that kind of looks kind of like this. So that'll give you the first graph like that. Okay. Now we can do the second graph. Now the second graph is a line. So this one is y equals 2x. It's really 2x plus 0. So that's just got a y-intercept of 0. And then the slope is 2 over 1. So you can just go up 2 over 1, up 2 over 1, and so forth like this. So you can just do that one. You can do it on your calculator too if you want to, but I'm just going to sketch that one in by hand like that. Okay, so now we've got a pretty good graph of what we want to look at here. Okay, so looking at this thing now, what we're trying to do is we're trying to find the area between these two curves. Now one thing that's obvious on here, the other part's not so obvious. So that part right there is pretty obviously a region that you can find using an integral. It's kind of hard to tell here, but I think there's a region right there too. There's something going on between those two right there. So what we're going to do is we're going to look at this thing. I'm just going to call this region 2, and I'm going to call that region 1. Okay? And the thing is, the reason I'm doing that is because the curves, the order is a little bit different. On my graphing calculator, one thing I'm going to go ahead and do, and you should do too, is just go ahead and graph 2x. And then let's take a look at it and make sure that these regions are looking right to us. So I'm going to go ahead and add in the 2x. Okay, now if you look at my calculator, I think it's pretty obvious on here that you have two regions that we need to set up. Okay. All right, so let's take a look at, I want to kind of zoom in on this. All right, so if I look at my graphing calculator, you can pretty well see the two regions. Okay, we got this right here, that region there, and then we got that region there. Okay, so let's set up our two integrals then. So the first integral, we'll just look at the area of region 1. Okay, now what we're going to do is we're going to totally use our calculator to find the intersection points on this one. Okay, so what you could do is you could solve this equation like that. You can solve that to find where the points intersect, or you can do it on your calculator. So this time I'm going to use technology. So if you don't have this in your calculator, go ahead and get both of those things in, adding the 2x, and then I'll show you how to get the intersection points. So what you do is you go like this. You go second trace, second trace, and then you go to option 5, which is intersect. And if you do that, you press enter. And then what you want to do is if we want to get this first intersection point, you just move that cursor so it's pretty close to that intersection point. Then you press enter. Usually a second curve comes up, and it's on the line, and then you just press enter again. When it says guess, press enter, and it'll tell you what that intersection point is. So that point is, and you can label it on your graph, that's the point -1, -2. So you can let your calculator do the work for you, okay? The next one is probably 0, 0, but here's how you do it on your calculator. You go second trace, option 5, and then just move your cursor so it's real close to that intersection point. Press enter. Next curve will come up. Press enter again. Press enter a third time. It gives you 0, 0. So like we expected, that point is 0, 0. Okay, everybody see what I'm doing? Okay, you can find intersection points on your calculator. You need to know how to do that. So third one, I go second trace, option 5. Then I just move that cursor so it's real close to the third intersection point. Press enter again, press enter again. This one is 2, 4. Okay, you could probably go for by looks on that, or you could solve this equation algebraically and you'd get the same answer anyway. Doing a problem like this, you're just as well to just let your technology help you. Okay, so let's set up the integral on this first one. Okay, so region 1, this thing right here, okay, where would you be integrating from on this little region here?
-1 to 0.
Good, -1 to 0. Left to right, you got to go in that order. Which curve is on top?
X cubed.
Good, the cube. So you'd have x cubed minus x squared minus 2x. Okay, see, that's the first integral that you're going to work out then. Okay, now we're going to go ahead and set up the second integral. Second region, where are you integrating from? Where to where? 0 to 2. X values, good. Okay, 0 to 2. Which curve's on top? 2x. So you have to do two integrals because the order the curves are in flip-flops. So then what you want to do is just work those two integrals out and then add the results, and then we'll have the area that's between those two curves. So that's the thing, is use your calculator to help you look at the graph, find the region, and then set it up. Okay, everybody okay with that? Okay, let's go ahead and put it all together. I'm just going to do one integral at a time. So the first one, we're going to go -1 to 0, like terms. Let's see, we just have x cubed minus x squared minus 2x dx. So we're going to work that integral out. And then the second one is integral 0 to 2. Everything is backwards. So it's going to be -x to the third plus x squared minus 2x. I think I wrote something wrong on this. Two dx's there. Okay, that should be a minus 2x. Okay, and see, one thing you can do on this, like I said on the last problem, is once you know what this is, look what this is. It's just everything's opposite.
The second one,
except that's a plus. I just caught that. That would be plus 2x. There we go. Now we're good. Okay? All right, everything good? Okay, now let's go ahead and work this out, and then we'll get the answer to wrap this up in. Okay, so the antiderivative of x to the third is x to the fourth over 4. Antiderivative of x squared is x to the third over 3. And then we have 2x to the second over 2. We're going to evaluate that from -1 to 0. Okay? All right, then the next one, see everything's backwards. You're going to have negative x to the fourth over 4 plus x to the third over 3 plus 2x to the second over 2, evaluated from 0 to 2. Now I'm going to pause and give you we're going to go ahead and start into this section 14.2, which is the last section. Now I don't do anything on the final on 14.2. I would in a regular semester, but not in the summer just because of the time issue here. The thing that I want you to know how to do in 14.1, the best example would be probably example 1 and 2. I want you to be able to do something like that. Not the harder, longer ones. They're just too time consuming.